in this lesson, we're going to talk a little bit about review of some prior knowledge that you should have to help you in this unit. So the first thing we're going to talk about is some parallel lines and related angles that happen. So if we're thinking, and these are in Cornell style, so that's traditionally meant to kind of show you the left side, the topics, and by just what you have there, you can tell what's on the right side. You can use it that way or not, it's up to you. But when we talk about a transversal, we got to know what that is. So we're going to look at this picture here, and we have a set of parallel lines, K and F, and then we have a line cutting through them that is T. That is a transversal. So we need to kind of think about a statement that we can make. So we can say if line F is parallel to line K, and T crosses F and K, then it is a transversal. All right, so if we look here, we can see that that is happening. We have then some angles that are made. We've got them labeled 1, 2, all the way through 8. And because of this special relationship, some magic kind of happens and we have some relationships. So we have some interior angles and exterior angles. So interior angles, of course, and we're talking about the ones between the lines here and outside the lines, or interior, outside, exterior, just like your house. So if we're thinking about in between the lines, we're actually thinking about in between here. So then we would have 3, 4, 5, and 6. Those are all interior angles. So let's label those. So we've got angles 3, 4, 5, and 6. Those are all interior angles. The exterior angles are the ones that would be on the outside. So we have 2, 1, 8, and 7 on the outside. 1, 2, 7, and 8. We'll put them in order. So angles 1, 2, 7, and 8 are exterior. They're outside of our parallel lines. Now we also have some angles that are on the same side, and we have some that are on alternate sides, and that means of the transversal. So we'll look at our next section. I'll make this a little smaller so we can see our picture still. So we're thinking about, and we're talking about of the transversal. So we want to think about what's on the same side. So if we look on this side here of our transversal, because our transversal is right down the center here, these are on the same side, and then we have another set on this. They're on the same side. So we actually have two sets or two lists. So on the same side, we have 1, 3, 5, and 7. And we also have 2, 4, 6, and 8. Now, alternate sides would be on either side. So 1 kind of corresponds to 2, 3 to 4, 5 to 6, 7 to 8. But also, they correspond the opposite direction too. So we can think about 8 to 7, 6 to 5, and so forth. And we also want to think about what kind of relationships are made. So let's make our alternate sides. So we have 1 to 2, 3 to 4, 5 to 6, 7 to 8. And we also can think about the opposite sides. Anything that's on this side can also be the alternate to anything on this side, meaning that 5 and 8 can be alternate, 5 and 4 can be alternate, because they're on opposite sides of the transversal. Now, they have some very distinct relationships that it's important to know as well, and these should be prior knowledge things. So we'll talk about those briefly. So we have, when we have relationships here, we have corresponding, we have alternate interior, we have some postulates, some laws, some rules that kind of help us. We're going to talk a little bit more about those. All right, so here we're talking about our postulates, or our rules or laws that help. And when we first start, we have to kind of make a statement of what is true, what is given, before we talk about our laws or our postulates. So in this case, we're going to let F be parallel to K, which they are here and here. and T, which is here, be a transversal. So when that is true, then these laws happen, these postulates happen. So corresponding angles are thinks about if we were to pick this line F up and we were move it on top of K, the angles would go with it. We think about what's corresponding. It's like kind of a correspondent news anchor. They do something the same as the other, but in a different place, but they're congruent. They're the same. So in this case, we have 1, and if we pick F up and laid it on top, what would come with it would be 5, so 1 and 5. And then we also have 6 and 2, because they would be on top, or you could say 2 and 6. We also have 7 and 3. They would be on top of each other. And then we also have 8 and 4. So we're going to write those down. So we have 1 and 5. We have 3 and 7, 2 and 6, and 4 and 8. So those are corresponding angles, and they are congruent, meaning they have the same value. We use a little symbol, looks like a equal sign with a little breath over it. That means congruent. Means the same. All right, so we also have some alternate interior angles, and that's our alternate interior angle postulate. And so we're going to look at interior, so we're looking just inside. So we're thinking about inside of here, inside of our parallel lines. That's our interior. And we're looking at alternate. That means either or, either side. So these here, 3 and 6, would be alternate, and 5 and 4 would be alternate. So we have 3 and 6, and we have 5 and 4, those angles, and those are also congruent. Okay. All right, and our last kind of relationship, not the only one, but the last one we'll talk about, is same side interior. So we think about, we're still inside the parallel lines, and we're going to talk about interior. So let me do a little redo here. So we're still here, and we're doing same side. So we're talking about the same side. We're talking about on one side of the transversal, or one side of the transversal. Those angles together, so the measure of whatever this angle is and this angle is supplementary, which means the sum of them equal 180. So we have 3 and 5, and we have 4 and 6, and those are supplementary. So this is some prior knowledge that you should have. You should also know what vertical angles are, what kind of relationship they have when you have a straight line. So the sum of these equals 180 degrees. All right, we're going to talk about how to prove triangles. So we're talking a little bit today about corresponding parts of congruent triangles are congruent. So the CPCTC that you've learned before in Math 2. Quite a few ways that we can prove that triangles are congruent, and we're going to focus today on side, 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 and the postulate for that, and side, angle, side. But there are other ways. You have angle, side, angle, angle, side, and hypotenuse, leg. So this is just a definition. Side, side, side postulate is if 3 sides of a triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. Okay? So we know these little symbols here, 1 and 1, means those 2 sides, A, B, are congruent to D, E. Order matters. The way you write things matters, and that has a lot to do with when you do proofs or you're proving what you're saying. Talk about the other postulate, which is side, angle, side. And it says if 2 sides and the included, so included is important, included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. That is your postulate, that is your law. So we can look here, we can see A, B, C. is congruent to DEF. And we can think about the angles that they share. It's right in between the two sides. We're going to prove that this is a triangle RFL is congruent to triangle LAR, and we are being asked to use the example of side, side, side. So we're going to restate our given information. Remember that order matters. We always start about restating. So we were given RF is congruent to AL. And I'm going to write them separately. You could write them on the same line. And then RA is congruent to FL. And where I'm going, my ending is I'm trying to prove that triangle RFL is congruent to triangle LAR using side, side, side. So I'm going to go ahead and mark my pieces. I've got RF, so RF's here, and it's congruent to AL. And then I've got RA here, and it's congruent to FL. So those are some given statements. Now, I want to talk about how do I get in order. So if I look here, I have RF. So R goes to F in my given spot, and it's telling me RF up here in my given is congruent to AL. Well, I started with R here and then F, and here if my very first term is L and it goes to A. Well, I need it to say L to A, but up here it says A to L. So I need to do something to get that to switch. Well, if I look at AL, here is AL. I know that AL is the same thing as LA because of reflexive property. So let's use a different color here. So I know that AL is also congruent to LA. Okay, so that's going to help me get the right order there. We need to write given here, and this is reflexive. All right, so now we need to look at some other orders. So that's going to help us get in that order. Let's look at what else we have. We need to have it say FL and AR. But if we look here, we have FL and we have RA. That's not going to work. So we need to do some flipping around with that as well. So we have FL here. Also FL is also congruent to LF. And still reflexive property. So that's going to help us with that order. So we've got these two that we can use reflective, but we also, remember, we're doing side, side, side. Well, we have another side that we haven't counted for, and that's the RL here. So we think about the middle of this piece right here, and we haven't accounted for that. So we need to think about that. We don't have it written anywhere in our given statements, no RL or LR, but down here we have an LR, and we also have the RL. So we need to be able to show their relationship because they're backwards right now. We're going from R to L this way and L to R this way. We need to show that they're the same. So if we look at our line here in our piece, we have RL. And we could say it's congruent to LR because it's also reflexive. Okay, so now we have everything that we can use as far as showing reflexive, and we've got some given stuff, but we still got to get in order here. So we've got to do something to get us in the right order. Well, we already had RF, correct? And AL is where our first mess up was. We need to have it to say LA. So we're going to use something else to help us. So we need RF to show congruency to LA. Well, if we think about LA, and we go up here and look where LA was, and what originally RF was, it was at AL, we can see that these two here and here are alike, and we use reflexive property to see LA. So now we're saying RF is equal or congruent to LA. We are using substitution. So now we have those accounted for. Now we've got to look at the rest of the pieces. We had RA, and we have FL, so RA and FL were backwards, so we've got to fix that as well. So we're going to put another substitution, RA, we need it to be congruent to LF, and we can add LF here at the beginning, FL, and we had RA, those were congruent, and we know that FL and LF are reflexive, and they can now show the same way and also by substitution. So now that we have that, now we have everything in the right order, and we can prove that yes, RFL is congruent to LAR triangle by side, 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 and we are done with that proof.